Hello and good afternoon, CTS265 section 840 students for the fall 2015 semester at Anne Arundel Community College for the CCNP route course, and this is going to be a video tutorial on challenge number 2, where we're going to be challenged with taking all of our EIGRP knowledge to this point and configuring EIGRP on a pretty advanced setup over here on the right hand side. So I'll let you read through this on your own, but the highlights are that we had a colleague do some configuration. However, while he did do some configuration on the branch routers, it looks like the HQ router needs to be configured almost fully here. Currently the customer has only 2 branches. Alright, so branches only have directly connected networks. Distribution center has many networks. Alright, so we should only get one update for all distribution center networks. So that's going to tell us that we're probably going to be doing a little summarization there from the distribution network. Alright, so let's go ahead and jump in here. Let's take a look. We'll start with the HQ router, and we'll go from user exec to privilege exec into global config and say do show run section EIGRP, and as you can see, there is no EIGRP configured on the HQ router. So let me go ahead and take a look here. It's going to be a good idea. Let's go ahead and pull up branch 1, branch 2, and the distribution. And what we're going to do here is say show run section EIGRP, because we want to learn the EIGRP autonomous system number. So we don't know what the autonomous system number is, and so on the HQ router, our first step is going to be to take a look at that. It does say use process ID 1 here, but I always like to confirm, right? Trust but verify to make sure that that's what we see. So show run section EIGRP. And it looks like we've got all the interfaces on branch 2 activated, and then on branch 1, go from user exec to privilege exec into global config, and let's say do show run section EIGRP. Alright, so we're EIGRP all the way around. So on the HQ router, let's do a do show IP. So do show IP interface brief. Let's see what interfaces we have here. We've got 2 serial interfaces. We've got 3 Ethernet interfaces. And so what we could do here, and it doesn't say whether or not to use named mode. So let's go ahead and let's try to tackle the HQ configuration with named mode. And we know from our previous discovery activity, the command will go ahead and downshift our metric calculation to 32-bit, and we know how to do that. So let's go ahead and fire up EIGRP here. So I'm going to say router EIGRP CCNP, and that is our goal here, is to get that CCNP. So now we're going to be in named mode. So if I say do show run section EIGRP, you can see that that's all we've got right now. So, and it looks like, let's take a look at the, actually let me pull that back and say do show IPv6 interface brief. Okay, so no IPv6. It looks like we are all IPv4 here. Alright, so I'm in the router config section, so I'm going to say address family IPv4 unicast for autonomous system 1. Alright, so the first thing we're going to do is I'm going to say metric version 32. And actually, is that under topology base? Let me see. Yeah, metric version 32. No, it doesn't like that. Is it version? I can never remember the command. Let's see here. Yeah, no, metric version 32. So it may not let us downshift. So that's okay. We're going to drive on with the configuration. We're going to stay in name mode. So let me back out of topology base here. Alright, so we're in address family IPv4 unicast. So here's what I'm going to do. I'm going to say AF interface default, and I'm going to passive all of the interfaces. And I'm also going to shut all of the interfaces down. I'm going to pick off the interfaces that I want one by one here. So let's go ahead and back up one level, say do show IP interface brief. Now the 209.165.201, let's take a look here at our diagram, and the question is, it's got to be for the 209. My guess is that is the interface for the 209. So do we want EIGRP sending hello messages out that interface? Probably not. So we're going to go ahead and leave that as passive. However, Ethernet 01, 02, and then our two serial links, we definitely want EIGRP to be running on those interfaces. So let me go ahead and drop back into config mode here, and let's jump on the HQ router, and we're going to go ahead and say, let's see, we've got 192.168.1.0. So I'm going to say AF dash interface, and let's go into Ethernet 01 first. I'm going to say no passive interface, and we're going to say no shutdown, and then I'm going to say AF interface Ethernet 02, and we're going to say no passive interface and no shutdown. And then let's get our AF interface serial 10, sorry about that, 10, AF interface serial 10, there we go, and we'll say no passive and no shut, and then finally AF interface serial 11, and we're going to go ahead and say no passive and no shutdown. Now, you'll notice I haven't entered in any network statement yet, right? And the reason for this is I want to go ahead and pick off the interfaces which I want to have EIGRP running on and make sure we've got the router where we want it before we enable EIGRP on any of the interfaces. So I'm going to back out one level now, and then here we are. Because remember, we're doing IPv4 and IPv4 only in this activity, it looks like. So I'm going to say network, and actually before I do that, let me do the do show IP interface brief real quick. So I'm going to go ahead and say network 192.168.1.0, and I'm just going to go ahead and hit enter here. And as you can see, the adjacency just came up. I could have put 0.0.0.255, and I'm assuming that's a /24 if I were to say do show run interface Ethernet 01, and actually it's a /30. However, even with the 192.168.1.0, it falls within the /30 range. Even with that /24, it's kind of a supernet. So to be technically correct, I should have said 0.0.0.3. So let's say do show run section EIGRP. Let's make sure we only have one network statement in there. So I'm going to say no network 192.168.1.0. And we'll leave it with just that single statement. And so you can see that it did not tear down the neighbor adjacency because we do have a statement in there that covers it. So let's say do show IP interface brief. And let's get that next network statement in there. So 192.168.2.0, and I'm going to assume that that is do show run do show run interface Ethernet, and that is 02, and that is a /30, so we'll put that in there as well. And then do show run int serial 10, and then serial 11. I'm just checking to make sure that we're dealing with all /30s. We are. So let's get that next network command in there. So 192.168. We did the 2.1, so now we're 3.0, 0.0.0.255, because I'm trying to constrain, and not 255, I apologize. .3 for 252. I'm trying to constrain the interfaces on which we're firing up EIGRP to be only those interfaces we need it running on. So then we're going to say network 192.168.4.0, 0.0.0.3. And so now, and there's our adjacency. Now if I say do show IP EIGRP neighbors, let's use some of our verification and validation commands. You can see that I've got an adjacency with 192.168.1, .3, and .4, but not .2. So I definitely want to make a note of that off to the side, that we need to come back and take a look here at .2 to see what may be wrong, a typo. Maybe there's some branch configuration that needs to be done. So do show IP, or do show run section EIGRP, and here's where we're at right now. You can see I've got AF interface default shut down and passive, and then for Ethernet 01, 02, serial 10, and 11, we've got no shutdown and no passive interface because we want those interfaces participating. And then under the topology base, it's dropped our network statements in here for us. You can see the network 192.168.1, all /30s. However, remember, we don't have an adjacency right now, and it actually didn't list out which is 192.168.1.2 would be Ethernet 02. So it looks like right now something may be going on here between branch 2 and Ethernet 02. So let's also check out on the HQ router. Let's see, what else can we see? So do show IP route EIGRP. So you can see we're learning a whole host of routes. The majority of the routes coming from the successor 192.168.3.2. Remember that via, right? This line here, via, that is our successor. This is how long the adjacency's been up, 1 minute and 41 seconds. This is out the local interface on this router that I would go to get to that neighbor. Here is my metric, and here is my administrative distance, and here's the route. So I've got a route for 10.0.0.0. I'm learning a route for 10.1, 10.2, 3, 4, 5, and 6. And then from 1.2, the successor 1.2, we're learning about the 172.16.1 and 172.16.2. And as you can see here, we've got the same metrics. And we're learning all internal EIGRP, administrative distance of 90, right? That D stands for dual, the diffusing update algorithm. So let's go ahead and clear our screen here. All right, so we validated that we're not seeing branch 2 right now, and we also are not learning any routes, obviously, from branch 2. So let's go ahead and take a look over on branch 2 and see how branch 2 is configured. So we can see here that this is classic autonomous system mode for EIGRP based off of the fact that the router EIGRP statement doesn't have a word, it has a number. So let's see what we've got. We've got EIGRP enabled on all interfaces. However, take a look here. Passive interface default. So on named mode, we go into AF interface default. However, when we've got autonomous system / classic mode, we can place the statement passive interface default. And then we can pick off the interfaces that we no longer want to be passive. Now, anything you see here that's striking, I'm pretty sure that our EIGRP peering between branch 2 and the headquarters router is not taking place over loopback interfaces, right? And if we were to clear this here and scoot back over to the diagram, it's going to be over Ethernet 00, right? And on the headquarters router, it's Ethernet 02. Okay, so here's what we're going to do. We're going to correct that right now. And so in order to correct that, we would go into our configuration on branch 2 and say, we'll go from user exec to privilege exec into global config, and we're going to say router EIGRP1. And I'm going to, let's first do a do show run section EIGRP. We're going to do a no passive interface, but we want to see that the 3 loopback addresses, that's what it's set on. So no passive interface, and then Ethernet 01, I believe. Let me double check again, I've already forgotten. 00. So Ethernet 00 on branch 2. So as soon as I do that, we should see, and that was rather quick, you see the adjacency came right up. So new neighbor 192.168.2.1. So let me go ahead and say do show IP EIGRP neighbors. And as you would suspect, the HQ/hub router has formed an adjacency with branch 2. So do show IP route EIGRP. Let's see if we see some routes and take a look at that. We're definitely learning the whole, all of our routes from the HQ router, because that's really the only router to which branch 2 is connected. Right? You can see it's got a single connection here over the WAN. And branch 2 has 3 loopbacks. So now that we've confirmed, we've got that no passive interface set, we've got the adjacency established, let's step back over to the HQ router. I should see some new routes coming from do show, and actually, is it keyed up in there? There it is. And I should see some new routes coming from 2.2, and I do. So here's the first successor we're learning from, which is 3.2. Here is the second successor we're learning from is 1.2, 192.168, 1.2. And then finally, we have these addresses here that we've learned, loopbacks, and these are coming in from branch 2. And again, you can see right here, it's out Ethernet 02. And let me confirm that again. I like to double check this. Yeah, out Ethernet 02. So back to the headquarters router here. All right. So we've got our adjacency established. We're learning routes, the distribution. So we're going to lessen overhead there. So let me go ahead and clear the screen here. All right. So it doesn't appear that anything else needs to be done on these two. So let me read. Currently, the customer only has 2 branches. They're planning on more. So you're required to limit the number of query messages. So we're definitely going to want to do some summarization. We may even go with a stub router. And hold on one second. Branches will only have directly connected networks. Distribution has many networks. All right, so here's what we're going to do next. We're going to go ahead and we're going to deal with the static route right now. So let's take a look here on the HQ router. Do show run section route. And I'm looking to see, and there it is. Perfect. All right, so we have our static route configured already, and it goes out to our internet-facing connection here. I'm sorry, this is Ethernet 00 right here, out to the internet. It's got to be that do show run int Ethernet 00, and there's our 209 out toward the internet. So what we're going to do now is we're going to redistribute that address family IPv4 AS1. And here is where we would do, under the topology base, we're going to go ahead and step in here, and this is where we would do our redistribution. So I would say redistribute static. Now, I'm not going to set the metric. I could set the metric for redistributed routes, and I could also use a route map here. Let's say I had 15 static routes defined on the router. So I could certainly do a redistribute static statement with a route map constraining the routes that are going to be basically leaked out here or allowed to be redistributed. However, we only have a single route, so we'll just go ahead and say redistribute static. I'm going to hit enter, and let's go over to, let's go over to branch 2 where we've been doing some work, and let's say do show IP route Eigrp, and it looks like we've been able to get that static route out there right here. And you can see that branch 2 is learning it from the headquarters router. That is the successor. That is my successor route. And the key, it's an external Eigrp route, so the administrative distance is going to be 170. All right, let's quickly look on branch 1 and show IP route Eigrp. We'll come back to branch 1 there with a big typo, and then show IP route Eigrp. And there we go. The static is being learned there. And then back to branch 1 here, who is still not cooperating. There we go. Show IP route Eigrp. And so that static route has been picked up everywhere. Okay, so to lessen the overhead, HQ should only get one update for all distribution center networks. So what we're going to do now is on the distribution, so a single update, so that basically is calling for a summary. So let's get on to that distribution router here, and let's say show IP interface brief. All right, so a single advertisement for all of the routes. Now those serial, okay, so those are directly connected. So it's got to be talking about those loopback addresses, and I'm going to make us some space here at the top because we're going to be dealing with doing some summarization, right? And again, great idea to work this out by hand so that when you're faced with this, when and if you're faced with this on an exam, you'll be ready to tackle it right away with great expediency. So when we take a look at this, right, remember, we're looking for the interesting octet. So the first octet, not too interesting, pretty boring, all tens. The second octet, however, is very interesting. So we've got 7 total networks here, and 0 through 6. So let's go ahead and break these down into binary. So for 0, it's going to be probably the easiest one of all zeros. For 1, it would be 0, 0, 0, 0, 0, 0, 0, 1. For 2, it would be 0, 0, 0, 0, 0, 0, 1, 0. For 3, it's going to be 0, 0, 0, 0, 0, 0, I'm sorry, yeah, 1, 1, there we go. Lost track of my zeros. For 4, it's going to be 1, 2, 3, 4, and then 8, 4, 0, and 0. And for 5, it would be 0, 0, 0, 0, 0, 1, 0, 1. And then 6 will be 0, 0, 0, 0, 0, 1, 1, 0. All right, now changing up the colors here, we'll go to yellow. We've got a black background, so this should work well. So where in the bits here, in the low order bits, we can see we've got sort of a hodgepodge as we kind of get closer to the 3rd low order bit here. That spot right there. So let's see. So these are all zeros. These are all zeros, 0, 0, zeros. However, it's here at the 6th, 2, 3, 4, 5, at the 6th bit, where the 6th bit is no longer the same. And again, that's our 5th bit, and this is the 6th bit here. So it's no longer the same. So when I take a look at this, I see we've got 0, 1, 2, 3, 4, 5, 6. So we've got a total of 7 networks. And remember, this is important, because when I take a look at this, I've got 1, 2, 3, 4, 5. So the first 8 bits already match, right? Now the next 5 bits match, so we know that we're going to be dealing with a /13, right? So that is going to be our subnet, or I shouldn't say our subnet mask. That's the subnet mask insider notation, and then we'll work out the details here in a second. So from the subnet mask perspective, if all 8 bits match in the first octet, we've got 255. If only 5 match, we've got 128 plus 64 is 192 plus 32 is 224. Make sure that's right. Yeah, 224 plus 16 is 240 plus 8 is going to be 248. And then everything else will be zeros, right? So let me draw a line here, because I'm not trying to say 255, 248, 00/13. So this 255.248.0.0 is our subnet mask, and that is the subnet mask insider notation. Okay, so what is our summary going to be? Well, it would be 10 in the first octet. We have no values that are on here in this second octet. So 10.0.0.0/13, which is going to include 10.0, right, where we start out right here, 10.0, up to, we're including up to .6. However, remember, it's always good to know how many networks I didn't match in my summary, right, that I had left out in this summary. And there are a boatload. So, because remember, if this was, say we were dealing with a /24, we would be talking about 8 networks that we were looking to match. However, this is a /13, not a /24. So we've got 8 bits here, and we've got 8 bits here, and we've got 3 bits here. So 21 additional bits that we could carve up and use for subnetting if we wanted to. So make sure you're aware of that when you take a look at how many subnets you're actually representing. All right, so that is going to be our summary. So let's go ahead and clear our screen and get the summary entered in. So let's go here, and again, I'm on the distribution switch, it looks like here. So we'll go in from privilege exec to global config, And let me say do show run section eigrp. Let's see what we're dealing with here. All right. So if I were to say do show IP protocols as well, and we could come down and we can see, and that is not what I was looking for. Do show IP Eigrp topology. Hold on one second here. No, I'm looking for do show IP protocols. Oh, because I'm sorry. I was checking to see if there were any passive interfaces, and it's show IP protocols, but I had thought I had seen one of those interfaces as passive, but the problem is do show run section eigrp is they are all no passive. So any up interface on this router is not passive, which is why it's not listed here down in this bottom section, which is typically where you would see it. So I am seeing what I would anticipate I should see. Okay, so let's go ahead now and apply the summary. So remember, in classic autonomous system mode, where is the summary applied? Where do we go do that configuration? Exactly, we do it under the interface. So do show IP interface brief. This is going to be on the two serial interfaces, and we can see that in our diagram here. It's going to be serial 2.0 and 2.1, and it's on those interfaces that we would do our summarization statement here. The yellow's kind of losing its appeal out here with the white background. But you can see serial 2.0 and 2.1, that's going to be, and hold on just one second. Sorry about that. So we're going to place it on the two serial interfaces. So let's jump back onto the distribution router and let's get an interface serial 2.0. And I'm going to say IP summary address eigrp1, and then here is where we put our summary in. So we know it's 10.0.0, and remember, what was our network mask? It was 255.248.0.0. If I had a leak map, and we'll come back, maybe we'll come back and do a leak map here toward the end so we can just get a chance to look again at route manipulation. So I'll go ahead and hit enter. Now, a couple important things are going to happen here. You can see we've got this graceful resync that takes place. However, let me go over to branch, let's see which one's furthest away, branch 1. So here on branch 1, you can see that initially we were learning about all, and actually, did it kill my, there we go. We were actually learning about all of those networks, right? So let's see what we're learning about now. What do you think we're going to see? Do you think we're going to see a summary for all of those networks? Do you think we're going to see only those networks, or do you think we're going to see a combination of the two? Let's see. Show IP route eigrp. And pretty interesting here, right? So what do we see? There's my /13 summary, right? Which is why I wanted to make sure we talked about that CIDR notation. And then here are all of the routes. So the question is, I just did the summary, so why am I seeing both the natural routes and the summary route up here on branch 1? In fact, if we go over to HQ, what do you think we're going to see? Are we going to see both, or are we only going to see one or the other? So show IP route eigrp. Sure enough, we see both. Here is my summary, and there are my routes. So what do you think it is? And you can kind of tell, if you look down here, you can sort of, this is kind of telling a story to us, right? So on which interface am I learning the summary? Well, I'm learning it on serial 1.0. On which interface am I learning all these other routes, all the component member routes of this summary? Well, I'm learning those on serial 1.0. So remember, if I've got redundant links coming from my distro layer, in order for the summary to be effective, I have to place it on both of my serial links. So let's go into interface serial 2.1, and we can actually probably recall that exact same command. So we're going to say IP summary address eigrp1 10.0.0.0 255.248.0.0, and we're going to hit enter. We're going to get a graceful resync here. And now let's go back over to branch 1, and let's rerun that command. And now what do we see? All of the component/member routes are gone, and all that is left is my 10.0.0.0/13, which is our summary route. Sorry about that. Which is our summary route. So now that we have this summary, let's do a little validation. Can I ping any of those networks? And let me actually get a quick accounting here. So 00101. Okay. So I want to get a quick accounting of those IPs. So let's see. Do I have reachability to those IPs? So 10.0.0.1. We can reach it. How about 10.1.0? 2.0. So is the summary working? It is. It's working fantastic. Now, when we talk about, and again, another critical point, very subtle things taking place here. So before, when we only had the single summary, so if I come back to serial 2.1 and I say no IP summary address, IP EIGRP, and I've sort of hinted about this, we've talked about this in a number of the videos where we talked about Layer 3 traffic engineering using summary addresses, or more correctly, when we were using leak maps, where we wanted a specific route to be leaked because it, again, remember, iOS, when it's making its routing decision, the #1 criteria will be the longest match. So wherever it finds the longest match in the routing table, that is the path it is. Excuse me, that's the path it's going to follow. Okay. So if that's the case, right, and we'll prove it right now. So if that's the case, and yellow is not going to work on this white background, so we'll go black here. So the summary is configured here. The summary is a /13. All of the /16s are being advertised out that link, and we can confirm that on the HQ router. We can see which routes are being learned here, and we can see which routes are being learned here. So the summary is being learned here. However, the natural /16s are being learned here, and /16 is longer, right? It's going to be a longer match than a /13. So we're going to suspend reality here for a second, or at least suspend the scenario here for a second, and we're going to say that what the provider really wants here, this distribution center networks, is for all traffic coming through the HQ router due to the distribution center networks. For the loopback interfaces, we want all of that traffic to go this way, right? However, we still want to summarize on serial 2.0. So I want to do a summary here, but I want all traffic to come this way, so that if for whatever reason this link goes down, we still have a summary in effect, and then we get a single advertisement, which may alert us to the fact that, hey, we've lost this link over here because we're no longer seeing our /16s. But again, that's, in the real world, not too likely. You're going to be monitoring this somehow. But we're just kind of suspending reality so that we can see what longest match routing does and how it works, right? And what it's going to look like. So I've got a summary here, /13. We've got the natural routes, which are /16s, the component routes being advertised on serial 1.1. So let's now go back to the HQ router. Let's validate that with a show IP route. And do we have reachability? We still have reachability, right? So that never changed. Show IP route EIGRP. I've got my summary as well as the /16s. I've got my /13 summary and the /16s. So let's step over to branch 1, and now let's say trace 10.0.0.1. And let's see, does it hop over the serial 1.1 link or the serial 1.0 link? And we are anticipating it's going to go over the serial 1.1 link on the HQ router to get into the distribution or the data center networks that are there. So there's our first hop, which takes us into the HQ router, and now the second hop should take us over the serial 10 link, I believe. There we go. So 4.2. So here we go. So the jump was from, on branch 1, 192.168.4.2, and we're anticipating that that is going to be this interface right here. So let's confirm that by jumping to the distribution network, and all we need to do is scroll up just a skosh, and sure enough, that is the serial 2.1 interface on the distribution network, and that is the interface that we went to, and 2.1 connects to serial 1.1 on the HQ router. If we ran that again, we are going to see the exact same thing, because what we're not doing is we're not doing any kind of equal cost load balancing here. We're simply making the longest match based on the summary. So there we go into the HQ router, and then we should see 192.168.4.2, and there it is. And so this is how, with summarization, you could do layer 3 traffic engineering. So let's go back to the distribution router. Let's go ahead, let's put our summary back on here, and we'll probably circle back with a leak map. We know that this works, right? So let's see. I'm reading the scenario here. I want to make sure that we've got everything down. We've got the static out there. All right, so we want to, you want to limit the number of EIGRP query messages. Branches only have directly connected networks. All right, so I'm assuming that the reason they're saying the branches have a single connection is that we want the branches, we want to limit the query scope. So what we're going to do here on branch 1 and 2, but not on the other, I guess the distribution center has many networks. That statement's probably there indicating not to do, set that as a stub. So we'll go ahead on branch 1, and let's say config T, we'll go into router EIGRP1, and I'm simply going to say EIGRP stub. So what is it going to, and this tears the adjacency down, this is disruptive, and if I were to say do show run section EIGRP on branch 1, what would we anticipate that EIGRP stub statement is going to have after it in the config? You've got it, connected and summary, because those are the defaults. And so that's exactly what we want. So this definitely limits our query scope, because HQ, if we were to come over here and say, oops, don't want to trace there, sorry about that. So we want to say show IP EIGRP neighbor detail. So let's take a look at how the headquarters router sees, and black is not going to work on black, so there we go. So right here, there is how the HQ router sees router 1 as a stub advertising the connected and summary routes, and he is suppressing queries over to that stub router. However, all these other routers, they are not stubs. So let's go ahead and make that change here on the branch 2 router. We'll configure him as a stub, and we'll go from privilege exec into global config router EIGRP 1, and we're going to say EIGRP stub. All right, and so he'll do connected and summary. So there are no summary routes here. The summary routes are all over on the distribution. So we could take the summary off, but it's not going to hurt to leave the summary statement there, because obviously we're not doing any summarization. So it's not a problem if we have that. So if we come over to the HQ router now and I say show IP EIGRP neighbor detail, we can see again here that now router, or branch 2 I should say, that branch 2 and branch 1 are both seen as stubs with the default connected and summary. Again, They're not doing summarization, so I could probably just say eigrp stub connected, and that would be okay. But I guess that does not, and no restriction here says we can't have that in there. So I'm going to go ahead. We'll leave that in here. So let's go ahead and on the HQ router now, to lessen the overhead, HQ should only get one update for all distribution center networks. So we've got that with our summary. 2 links between the headquarters and distribution center routers. Because these 2 links are weak. Okay. So this final requirement here, because these 2 links are weak, which then they should say maybe they're slow, the customer requested that both links are utilized at all times. They need all the bandwidth that they can get. So let's take a look. Whoops. Let's take a look at the routing table one more time. Show IP route eigrp. And you can see, what do we have between those 2 networks? We've got a single successor here, right? And the next hop goes to 3.2, which should be the serial 2.0 interface on the distribution router. And let's confirm that. So serial 02, yep, 3.2 is serial 2.0. So, but it is 3.2. So as you can see on the HQ router, are we currently using both links here? So there is no equal or unequal cost multipathing taking place. We're certainly not doing ECMP, equal cost multipathing, right? Not happening here because I don't see 2 successors in here. So now let's dig in and use some of our topology table knowledge to see, what that should look like. So if I were to say show IP eigrp topo, we'll get a look at the topology table here, and we're probably, as soon as you notice that there aren't two successors in the rib, it's probably a pretty good bet that we're going to have to use the variance command, right? Because if there were 2 successors, we would have had what? Correction. If there's 2 successors in the routing table that have equal metrics, we would have what? Equal cost multipathing, right? So, but we don't have that. But we do know we have 2 paths. So let's come in. Let's take a look in the eigrp topology table, and the good news is that it shows both of the successors here. And what does that mean if for that successor route we have the successor listed first and then we have who listed second? Exactly, our feasible successor, right? So this is good news because it means that he meets the criteria to be used in unequal cost multipathing. So we're going to do unequal cost multipathing across these 2 routes that do not have equal costs. As you can see, the cost for the successor is 1.8 million, and the cost for my feasible successor is 3,139,840, right? So, given this, we know that he meets both criteria. And by he, I mean our feasible successor, because he can guarantee loop freedom. And how do we know that? We know that because his reported distance is less than the feasible distance of the current successor. Who's this guy right here, right? So if he meets the feasibility condition requirements where his reported distance is less than the feasible distance of the current successor, check the box. We got loop freedom here, and we've got a feasible successor. And remember, only feasible successors can be used for unequal cost multipathing. You cannot use routes that are not feasible successors. Cannot be done. Okay, so we take a look at this here. We see that, yep, this guy meets the requirement. So now the only question is, we know we've got to use the variance command. How in the world do I take 1 million 1,889,000. I'm sorry, I'm writing and looking up here at the same time, trying to keep this all straight. 1,889,792, which is the feasible distance. And I know that the reported distance, and that's of the successor, and the feasible successor says, hey, my reported distance is 128,000. Is that right? 128,256. And that is correct, and that is because we are using, so we're seeing the metric as extremely low there, because that's what's being reported to us as a 32-bit metric. All right, so this is going to be a little challenging here. So let's check this out. So now as we look at this, there's a very simple way to figure out what the variance is supposed to be. And that's if we divide 256, divide the successor's feasible distance by the reported distance of the feasible successor. And I have to admit here that I am not certain. Let me get the calculator up here. Where's that calculator at? I am not certain with this 64-bit metrics how this is going to turn out. So let's check this out here. So if I were to say 1,889,792 divided by 128,256. So we get 14.7, right? Now remember, EIGRP uses integer math, right? It doesn't use floating point. So we're going to round that up, and we would have to use what? So if we used 15, we would be in the clear. So let's go ahead and say 15 times 128,256. And that's going to give us 1.9238 million. And actually, as I'm looking at this, that is, let's see, 1, 2, 3, 2, 3. Is that going to work? So I really need, what I really need here is I think we really need to downshift this. Let me clear the screen here. Whoops. And that's how that tab was popping up there. So let me clear the screen here. And let's do this real quick. So we might have been too clever by half on this one by do show run section EIGRP. So we decided to do the named mode with all of our config. So router EIGRP, and we used, I think, CCNP. Is that correct? Yes, CCNP. So we're going to say address family IPv4 AS1, and the metric version 32 did not work. It did not like that. And even under topology base, it did not like that metric version 32-bit. So we may be stuck here. Let's see. So if we were to manipulate that, do show IPEIGRP topology, and let's see how we're going to deal with this. So 1.89 million. And actually, kind of in a conundrum here where I don't want to tear down the oh, and you know what? Now that I'm looking at this, I think I was working with the reported distance, and what I really wanted to be looking at was the metric cost on that variance. So I apologize. Now that I'm looking at this, yeah, I grabbed the wrong number when we were talking about the variance. So yeah, in looking at the, yeah, okay, I apologize. I grabbed the wrong number. So we're looking at the talking about the feasibility condition, and I ended up, was correct there, but then ended up talking about the reported distance. So variance, when we're talking about the variance, let me clear the screen here. The metric of the feasible successor. So the reported distance That's what we're looking at to say, is it less than the feasible distance of the current successor? Does it meet the feasibility condition? It does. At that point, I should have stopped and said, okay, now we know we've got to use the variance command, and it's going to be with these two numbers here. So I need to increase, I need to increase the computed distance, and we'll call it, it's the feasible distance, are the same right now. So I need to increase this value so that the computed distance of the feasible successor is less than the feasible distance of the current successor. And so, again, we've got the feasible distance is 1889792, and my metric, let me pull that back, computed distance. The computed distance of the feasible successor, that's the successor, is 3139840. So in looking at this, right, we can probably tell where we're going to come in at. It's probably going to be 2 or more. So what we need to make sure of is on the variance, this is the feasible successor's current metric. In order to get him into the rib as a successor, we need to increase by the variance variable the feasible distance of the current successor, or I should be saying the computed distance of the current successor, so that the feasible successor's computed distance is less than this value multiplied by the variance variable. So now let's go ahead, and I apologize there by pulling out that reported distance value initially. Let's pull the calculator back out here. So again, the quick way to do it is to simply take the computed distance of the feasible successor, 313,984, and divide that by the computed distance, 1889792, and that's going to give us, and did I do that backwards? Let me see here. 1889792 divided by 313,9840, and I think that's where I'm getting the 0.16. So we got 0.16 prior to that. And let me make sure I typed all those numbers in. There's no way we should have gotten 0.6. 313, I must have missed a number. 9840. So let me double check. 313,840, and then divided by 1889792. Okay, yeah, I must have typoed it before. So we get 1.66, and here's where we want to round up, right? So we want to round up to 2. So let's go ahead, and we're going to drop in our variance2 command. Now, where do we do that? So you can see that I'm under the, and let me to make sure, we're in the topology base here, because this is going to affect everything. So I'm going to throw in here variance2. So as soon as I put variance2 in, what we should see when I say do show IP Eigrp topology is that we have 2 successors now, right here, and both of these guys qualify because we've tweaked the variance value from a default of 1 to 2. So now this value here is less than, so again, the computed distance of the feasible successor is strictly less than the computed distance of the current successor multiplied by the variance. There we go. Right? And so when you multiply that by 2, we get a number that is larger than that number. Therefore, we can install that feasible successor into our rib with a do show IP route Eigrp. And there it is. So now we have both of these in our routing table, even though they have different metrics. And so you can clearly see here that the metrics are different. And the only way in EIGRP that we would end up with two routes in here doing multipathing across these routes where they have unequal costs is if we have set the variance to something, to a value, to where that number right there of that feasible successor is less than this value of the current successor multiplied by the variance. All right, so that should, in reading through this here on the left, that should pretty much take us to the end of challenge number 2. So again, I apologize there. I got off task and grabbed the wrong value when we were talking about the variance. So again, remember, the variance is interested in the topology table, and it's making sure that the value of the current successor, the metric, the computed distance of the current successor, when multiplied by the variance value, in our case we use 2, that the feasible successor's computed distance is less than that successor's computed distance times the variance value. And then that will give us unequal cost multipathing. All right. Well, that's going to wrap up challenge 2, configuring EIGRP. Apologize for the confusion there on the variance, and enjoy your weekend. I will see you all on Monday.